Right, so we're recording now. If you have any questions about last time, if you could just put it in the chat area, please, because that's where I'm going to be looking, and I'm going to present you to my screen, and we're going to get on for the work for today. So hopefully you can see my screen right now. What I am going to do, I'm just going to go over a little bit about base 5. Now remember, I am trying to convince you that we have a number that when you multiply by itself, oops, what's happened here? A number that when you multiply by itself is going to equal -1. And we're going to find that in base 5. So in base 5, we use the digits 0, 1, 2, 3, 4. And so there are our first 4 numbers, 1, 2, 3, 4. So the next number, we can't use a 5. So we skip out 5, 6, 7, 8, 9. And we go to 10, 11, 12, 13, 14. Okay, yeah, we just started. And I'm recorded. Okay, Isabel's here. Good, thank you, Isabel. Yeah, I've got you there. No, we're on time. That's good. Then the next number is not going to be 15, 16, 17, 18, 19, but it's going to be 20, 21, 22, 23, 24. And continuing, for those, just in case others come along, this is in base 5. So we're doing all this in base 5. And this is looking at finding the number that when you multiply by itself, it equals -1. That's what we're eventually going to be doing. So we get up to 25. Can I have 25? No, I can't, nor 26. So we're just going to continue up to over 100. So we get 24. Then the next one will be 30, 31, 32, 33, 34. And then 40. 41, 42, 43, 44. I'm going to make a mistake here. 50. Can I have the number 50? Yes or no? And why or why not? No, because we're not allowed to use the digits 5. These are the digits that we're using, 0, 1, 2, 3. So I'm not allowed any of 50 or 60 or 70 or 80 or 90. So the next digit after 44, what's the next one going to be after 44? Anyone? What comes next after 44 in base 5? 44, base 5, 100. Good, 100. Then we go 101. Okay, now if you want to work out no, we won't do that. So that's base 5. So if we are adding 2 numbers in base 5, say 23 plus 34. Now 3 plus 4 is 7. I can't have 7, so that is 5 plus 2. 5 plus 2 equals 7. So what I do is I put the 2 down there and I carry the 5 over. Then we got 1, 3, 6. I can't have a 6. 6 is made up of 5 plus 1. So I put 1 there and I add 1 there to the 0, and it's 112. So when you add 23 and 34 in base 5, it comes to 112. Okay, let's do one more, and then I'm going to ask you, does this make sense? Because this is all I want you to do today, is just understand about base 5. We're going to come back and visit it. I'm going to build you up slowly to prove that there is a number, and when you multiply by itself, it makes -1. So let's do again, let's say 43 plus 122 plus 30. Right, we want this in base 5. 3 plus 2 is 5. I can't have a 5. It's made up of 5 plus 0. So I put the 0 down and I carry the 5 over to the next column. We get 5, 6, 7, 8, 9, 10. Can't have a 10. It's 5 plus 5 plus 0. So I put a 0 down and I carry 2 lots of 5 over. 2 and 1 is 3, so I get 300. in base 5. Okay, could you put over the side here, yes or no, if you follow it? If you understand how to do some base 5 numbers, just a yes or no. No one. All right, we've got one person saying yes, that's good. Welcome, Wes. One more example would be good. Thank you, Celine. That's why I need to know. I need to know this. So let's take, let's do 30 and 22 and 31 and 44. Okay, so we go 2, 1 is 3, 7. We can't have a 7, so we take off the 5. It's made up of 5 plus 2. This is 1 unit, so it gets carried to the next column. So we've got 2 and we carry over 1 lot of 5. We've got 4, 5, 6, 9, 10, 13. So 13, oh, we've got an answer there already. Wesley's beaten me. Let's see if he's correct, 232. 13 is made up of 5 plus 5 plus 3. So we're carrying over 2 lots to the other side, to the next column, and we're putting our remainder of 3 down there, and we've got nothing, nothing, nothing to add that to. So Wesley's correct, 232. So that's base 5. Celine, do you want one more example? Yes or no? Good. Anyone else like another example? Are you all good? So what I want you to do is to add in base 5. Tomorrow we're going, or next time we have maths, we're going to be doing multiplication in base 5. So that's something to look forward to. Okay, I mentioned last time that we have things called rational numbers. So just review this. Rational numbers are fractions. So that's A over B. There's one condition, that B cannot equal 0. You can't have anything over 0 because it's undefined. And then we have things called irrational numbers. Irrational numbers are your non-repeating, non-repeating, let's spell it correctly, non-repeating decimals. So those are your irrational numbers, non-repeating decimals. And we have irrational numbers. Pi is an irrational number, E is an irrational number, square root of 2, square root of 3, square root of 55 is irrational. Anything square root that is not a perfect square will be an irrational number. And when you learnt about numbers, you first of all learnt about natural numbers. Your natural numbers were the numbers that you started counting with when you were a little child. 1, 2, 3, can you count to 5? You learnt to count to 5 and everyone thought you were clever. And then they continue on forever. Then you learnt about whole numbers, which put the 0 in there, 0, 1, 2, 3. And then sometime, maybe about 7 or 8, maybe earlier, you got onto the integers. The integers included the negatives and the positives. And then you learned about fractions and decimals. So these are here, right? And all of these are called real numbers, right? So all of these, the integers, fractions, decimals, are real numbers. So I'm going to put real numbers there. They're all called real numbers. Now we're learning about irrational numbers. My question, do irrational numbers belong to real numbers, yes or no? Are irrational numbers real numbers? Have a guess. Irrational numbers, real or not? What? I want everyone's answer down here. Just have a guess. Oh, Tian's here. Good. That's the one way I can mark the roll too, so I can see who's here. So thank you, Tian. Offered an answer. Juan's here. Good. Well, this is serving a double purpose for me. I want everyone to answer yes or no. Here, I think I've already got Ethan. Oh, good. Someone's going the other side. We've got 3 no's, 1 yes. The rest are still waking up. Come on, class. Plug in those answers. Yes or no? Are irrational numbers part of the real numbers? Yes or no? Don't Google it. Just have a guess. Oh, Kyle's here. Good. Stephen is here and Colin is here. Good. Fatima, good. Yeah. And yeah, they are. They are actually part of your real numbers. Okay, so I'm going to just erase this out, and we're going to do this. Your irrational numbers are also part of the real numbers. So you've got natural whole, integers, fractions, irrational. But outside here, complex numbers are not part of your real numbers. And we're going on to complex numbers. They're not part of the real numbers. They're not classified as that. Okay, so you've learned something, some of you, that real numbers are there, right? So let's go on to the work for today. I'd like to just review these things over here. Now, I have asked you to do some of these things. This is one of the transums activity. Would you like me to go over the first row, which I'll call A, the second row B? I am going to go over C and D, but do you want me to revise A and B? I want to know if anyone says yes in here, we'll do a few examples of A and B. If you're all good with that, we'll move on to C and D. If you want me to go over A or B, let me know. Say yes, please. If you don't want me to go over A or B, say no. Am I getting the messages?
Yes, please.
Oh, okay. What am I getting? Right, so we've got a yes. We can. Right, so no one's typing in. Right, so I've had a yes to go over A and B. What we're doing is we're trying to make these numbers so that they are rational at the bottom. So if I take this one and I multiply it by the square root of 5 over the square root of 5, that's another name for 1, so I'm not changing it. And so this left-hand side would then become 15 over 15 root 5 when I multiply the top two together. There's the 15, there's the root 5, so it becomes 15 root 5, and then I divide it by the square root of 5 times square root of 5 is 5. And so my final answer would be 5 goes into 15 3 times, it would be 3 root 5. Just go over that again. I want to get rid of the denominator, the square root, so I times it by square root of 5. Square root of 5 times square root of 5 is 5. I do the same for the top because that's the form of 1. When we multiply something by 1, we haven't changed it. You simplify your top, your bottom. 5 goes into 15 3 times. So for the next one, I'm going to multiply this by square root of 3 over square root of 3. This is going to give me 3 on the bottom. So I get 12 root 3 over 3. Whoops, I didn't finish that. I've got minus root 20. That is not finished. So we'll finish this one on the right, then I'll go back. Minus the root of 27. Now 3 goes into 12 4 times. So I end up, I'll just get rid of some of these things over here, my base stuff. Just won't be long. This will give me a bit more room to write things. Right, so we're doing this one, 12 root 3. So I'll just write it over here. We've got down to 12 root 3 over 3 minus root of 27. There's nice and neat. 3 goes into there. 4, that's 4 root 3. Now 27, we can see a square number in there, 9 times 3. And so we've got 4 root 3 minus the square root of 9 is 3, 3 root 3. That equals 1 lot of root 3. So my answer to this one here is just square root of 3. Now let's go back to the other one I didn't finish because I wasn't paying attention. We've got to do minus 20. So let's just copy the whole question out again, start it again from the beginning. Really messy. So 15 root 5 minus root 20. Let's draw it over here. 15 over root 5 minus root 20. So I've got to multiply the top and the bottom by square root of 5. That will get rid of my denominator. And so that's 15 root 5 over 5 minus 20. Is there a square number in 20? 4 times 5. 4 is the square root. So 5 goes into 15 3 times, 3 root 5, minus square root of 4 is 2, so 2 root 5. And 3 root 5 minus 2 root 5 is just 1 root 5. So we get the square root of 5 as our answer in here. You can try some of those together. If you want me to do this third example, let me know. But I'm going to go on to this next example where we've got 6 over root 2. And I will just get rid of all this working over here. So I've got rid of that. Let's do this example here. There's 6 over root 2 plus 12 over root 6. So I'm going to do the same thing that I did before. I'm going to multiply this by root 2 over root 2. I'm going to multiply this one by root 6 over root 6. This gives me 6 root 2 over 2 plus 12 root 6 over 6. And I hope I've got that right. Did I copy it out correctly? Yes, I did. Right, so therefore we've got 3 root 2 plus 2 root 6. Is there any square number hiding in the 6 there? I can't see one. So this is going to be my final answer. I cannot simplify that down any more than that. So my final answer is 3 root 2 plus 2 root 6. And we'll have a look at one more example before I do the next one here, before I go on to the next line. And we've got 15 root 3 plus 30 root 5. Hopefully you can see the starting point. The starting point will be to times by root 3 over root 3 and root 5 over root 5. That will give us 15 root 3. We normally put the whole number first and the surd afterwards over 3 plus, oops, there should be a root 5 on the bottom, shouldn't it? Beg your pardon, that's a root 5 on the bottom. And then we got 30 root 5 over 5. Okay, now we have fractions on the bottom. Oh, they will simplify nicely. Let's get rid of this. And we can simplify this down to 5 root 3 plus 6 root 5. Okay, if you've got any questions on that, let me know. But we are going to, yeah, all of these are very similar, same sort of thing to do these. Perhaps I'll have a look at this one. It looks a little bit different. This one here, the top. And we will take that example and do that one as well. So we've got root 3 plus root 27 minus root 12. I'm going to look for square numbers. There's no square numbers under the root 3, but under the root 27, I've got 9 times 3. And under the 12, I've got 4 times 3. So, whoops, I wrote 12. 4 times 3. So I can go that this is root 3 plus, I can take the square root of 9 as 3 plus 3 root 3 minus, and this is 2 root 3. So what I'm doing is I've got 1 of these plus 3 of these, that's 4, minus 2 of these, the answer is 2 root 3. That's simplifying surds, leaving them in surd form. We need to be good at that for this topic. Put OK in the comments if you are OK with that before I go on to the next bit, because I don't want to lose you. Just a question, do we still, no, we're not doing the assessment this week, Isabel. We'll do the assessment next week, or when we get back to school. You must have missed out the lesson. There's a recorded lesson there for you to look at. Could everyone please type in the comments whether you've got the hang of that for the work that we're doing here, for the first few. Good, keep going. Cool. Tima, good. Right. If anyone else is struggling, you stay behind and I can give you some extra examples. For C and D here, we're going to look at what we call the conjugates. So when I multiply root 16 by root 16, that just gives me 16. And when I have a plus and a minus here, the difference of two squares, the middle term cancels out because this is minus root 16 plus root 16, which gives us nothing. Then 1 times negative 1 is minus 1, so the answer is 15 there. Over here again, we've got 10 plus 2 and 10 minus 2. These are called conjugates. The conjugate is where you've got one that is plus and one that's minus and everything else is the same. They're conjugate pairs. And conjugate pairs are very, very important in this topic. So please make sure that you understand what conjugate pairs are. Root 10 times root 10 is just 10, no middle term. 2 times 2 is 4, 10 minus 4 is 6. And the same here, 11 11s, that gives me that, minus 9, the answer is 2. Okay? So that when we're to rationalize the denominator on this one, I have to multiply it by the conjugate pair. So that's 4 minus root 7. And I have to multiply the top by 4 minus root 7. Why do I have to multiply the top by 4 minus root 7? Because this has to be 1. When I multiply something by 1, I'm not changing the value. So the denominator is 4 times 4 is 16 minus 7. That's my denominator, which the denominator is obviously 9. And then you go 27 times 4. You might need to get your calculator out for that one. I think that's 108 minus 27 root 7. Have I done that right for 7, 28, 4, 2, 10, yeah. And so my whole answer would be 108 over 9 minus 27 root 7 over 9, which would be 12 9s 108, 3 root 7. So there is my rationalizing of the denominator. And the next one, rationalizing the denominator down here. So we'll go over here and do it. We have got to multiply the top and the bottom. Actually, I'll start at the top here. We've got to multiply the top and the bottom by 3 minus root 5 over 3 minus root 5. So that gives me, when I multiply the top, it gives me 60 minus 20 root 5 over 3 times 3 is 9, and 9 minus 5 is 4. So that's going to give me 60 over 4 minus 20 root 5 over 4, 15 minus 5 root 5. So that's how we simplify that. On a piece of paper, go ahead and do this one here. Rationalize the denominator by using a conjugate of the denominator in the form of 1. And when you've done that, let me know. So Wesley got 8 square root of 3 minus root 3, he thinks. I got a slightly different answer, Wesley. So I'm going to have to check mine again. I think you might have got here 40 minus 5 root 3. That's better. 40 minus 5 root 3. Yep. Ah, yes, 5 bracket. Yes, you can factorize it. That's better. Wesley, good. Both those answers are correct. 40 minus 5 root 3. So you've learned how to do conjugate pairs today. So I'll put my answer in green here, red here. 40 minus 5 root 3. Okay, if you are having trouble getting that answer, stay behind afterwards and we will go over it. Okay, now I've got some questions here that I've taken off the exams section of Transum. I think that's where I took it on. And without using a calculator, we're going to show that root 28 equals 2 root 7. So here we're going to look at finding square numbers. So where's a nice piece of paper here? Blank area. So root 28, what does that equal? Do we have a square number hiding in here? I can see 4 times 7. And that means the square root of 4 times the square root of 7, which is the same as 2 root 7. You don't really need that middle line of working, but just go straight from there to there. And we've shown and done that answer. Right, so we've shown that it equals 2 root 7. The next point, it says that x is on a grid, unit grid. The point y is the square root of 17 from x, and it lies at the intersection of 2 grid lines. So it lies here, or here, or here, or here, or see, it lies on those various points. That's what we're looking for, to see which point it lies on. Possible solution of y. Mark one possible solution of y. How do we do that? So if we do a little bit of Pythagoras theory from x, we know that by Pythagoras theory, c squared equals a squared plus b squared. So if I can make 17, the square root of 17, or c would equal square root of a squared plus b squared. So if I can make the square root of 17 into 2 numbers that are squared. What 2 numbers that are squared can make 17? Are there any 2 numbers when we add them together, square numbers that make 17? So here are your square numbers. Well, there must be some of those lower ones. Hopefully that you can see that 1 plus 16 makes 17. That makes sense? 1 and 16 makes 17, very high-powered calculus here. So that's 1 plus 16 makes 17. In other words, 1 squared plus 4 squared equals the distance. So if I go out 1, up 1, 2, 3, 4, I could have y in this position. It's on the intersection of a grid. And if I now do Pythagoras theory here, and I put my triangle, whoops, that's a really wonky triangle. Let's do a bit better than that. Let's go and draw it in, insert the lines. Where are we? My drawing ability on this is not very good. We go there, and then we'll go, whoops, that's a bit too, we'll go there, and we'll draw another line down here. And I'm just going to mark on here that this is 1 unit. This is 4 units. 1 squared plus 4 squared, 16, square root of 17. So this line going up from here to here would be 17, square root of 17 units. I could have had other points also. I could have had going up 1 and out 1, 2, 3, 4. Y could be there. You could have gone down 1 along 1, 2, 3, 4. Y could be there. So there are several positions for Y that you could have had. Y1, Y2. So they're different positions. But as long as you have a triangle with 1 and 4 as the sides. Does that make sense, people? Yes or no? If you're following me, still awake? Someone clicked in, yep. Right, one person awake. Good, few people awake, good. Really, thank you. Okay, now, do a few more of these. This is just to help you underway so that you understand, so you can go ahead and do the activities that I've given you. So I will go on for another 5 or so minutes, maybe 5 or 10 minutes, and then you can do the work. 5 plus root 20 in the form of a number root 5. So we need to look and see if there's a square number in that 20 there. Remember, we're often looking for square numbers. So if I do root 5 plus 4 times 5 is 20, then I've got root 5 plus 2 root 5, which is going to equal 3 root 5. So a is an integer, it's the number 3, and we've got in the form of a root 5. This next one, I had a bit of trouble, so I better last night. I hope I've got my answers as I was preparing this. So let's see if I can do this. We have 1 to the power of 9 over the root 5 to the power of 9, because I'm putting that power over both parts. 1 to the power of 9 is still 1. And 5 to the power of 9 is, say, 5 to the 9 over 2. Now, we've got that. If I want this as an integer, I've got to get rid of the square root part. So if I times this by 5 to the power of 2 over 5 to the power of 2. By doing this, I'm multiplying by 1. So my top line, therefore, becomes 5 to the power of 2. And when I multiply these, I add the powers. That is not going to work. I've done it wrong, so I have to change it. It's not 5 over 2 there. I'm going to have to multiply it by 5 to the 9 over. I want to make that. I square the top and square the bottom. I knew I'd get stuck. Right, if I square the power of 2 over 9. No, this one here, the square root there, Celine, that 2 is always the fractional part there. Oh, you mean multiply by the power of 2 over 9. 5 to the power of 2 over 9. No, because we'd still just add it. Yes, 4.5 is correct, Bilal. So the power of 4.5. But what I want to do is I want to get rid of that squared. So if I square the top and I square the bottom, would that work? No, that wouldn't work because that's not 1. What I'm going to do is I'm going to look back and find what did I do last night when I did this. I prepared it, and since then I've forgotten how to do it. And where did I put my answer? Right, I'm going to come back to that question later. I'm going to think about it and I'll come back to it. I won't write this here. Right, for number 3, so I'm going to return to this. I will do this question later and explain it to you. Wesley, have you got it? 5 to the power of 4.5. Yeah, but this is 5 to the power of 4.5. I wonder what would happen if we did it on our calculator. 1 divided by 5 to the power of 4.5. That was the answer I got the other day. 5 to the power of 9 over 2 divided by 9. What did I do? Can't remember. I'll come back to it. For question 3, you just need to put all these in decimals, then you can write them in order. But this one here, if you want to write it in the form of a plus b root 5. So what we have to do is we have to expand this out. So we've got to go 1 plus root 5 times 1 plus root 5. Expand out 1 times 1. 1 times root 5. 5 times root 1. And 5 root 5, that gives you 5. We add our 5 and our 1 together. These bits here, 1 and 5 make 6. 6 plus 2 root 5. So there's the form of A. A is 6, and a number with the root 5. So it's really just understanding the question, and I hope you understand that. Okay, apart from question 2b, does everyone else understand the rest of it? Square root of 625 to the power of a half. Okay, Wesley's got a bit of a clue there. Square root of 625 to the power of a half. So let's see if you can finish that off while I have a think about it and catch up to where you are. And is that the final answer, Wesley? 625 to the power of a half. So that's the square root of 625. So Wesley's suggesting that this answer here, thank you for helping us out, is the square root of 1 over 625. Okay, now we have there some square roots in there, 25. So let's look out the square root. So 625 divided by 25 equals, and so that is 1 over square root of 25 times 25. Correct? I'm not sure where you're going with this, Wesley. We'll come back to that. Okay, so as long as you understand all those other things, let me know. I'll come back to that one maybe next lesson. But here's a good problem for you. I sort of like this one. Can you simplify this down? So that's your challenge. Before everyone goes, I just want to make sure that you know where to go for help on this. You go to your Google Classroom, and on the Google Classroom, there was the link. Yes, this calc, that's the video that I did yesterday. Go to your Google Sites. You'll get this one here, CAL3, which is off the screen at the moment. CAL3, go to the complex numbers. Oops, come on, complex numbers. Don't disappear on me, complex numbers. There we go. And under complex numbers, right, what I've got the lesson recording here. I've got the OneNote lesson, which will be here as well. Then I've got some worksheets with answers. So if you click on this, it will take you to a worksheet. And this worksheet, I'd like you to do it, just some practice on those, and it has answers down the bottom. Okay, so you can check your answers once you've got it. And there are not many, there are about 12 on each worksheet, or maybe less. So those worksheets I would like you to do. We've got quite a few there. I've put some up. Probably you might get the first 2 done. If you can do number 3, 4, and 5, that's going ahead. That is fine, but you can go ahead and do those. So that would be your work for you to do on complex numbers, is to go through these worksheets in order until you get stuck and don't understand it. And if you don't understand it, you can actually go back to these videos and they will teach you how to do it. So you can do some self-directed learning and go ahead, depending how much time you put in. Okay, so that's what you need to do. Are there any questions that anyone might have? So just a reminder, what I would like you to do, see if you can simplify that. That's an extra activity. You can do it now, or you can log off and do it later. We'll visit that next time, and we will have a look at that last question that I couldn't do as well. Celine, you got root 5 over 3125. Good. Thank you, Celine. I will check it, and I will get back to you if that is correct or not. To be. Well, you've certainly completed the question in terms of where it wanted you to go. I'm just having a mental block at the moment, so I'll get back to you on that one. So there's Celine's answer. Go ahead and check. So next lesson, we'll check 3B, and we'll check the answer to this question and do those worksheets. Is it all clear what you need to do? Yep, good. You can go and work independently. I'll be available till the end of this lesson, 10:20. If you have questions, just come back in here, log in. Otherwise, you can go and work independently. You can hang around and stay. If you need help, please stay back. I can go over any questions again for any of you. Thank you. Thank you, everyone. Cool. Thank you. And I'll upload this lesson also on to the classroom, onto the Google Sites rather. Daniel's here, good. Parang mas kailangan natin, parang mas